started trigonometry identities last week. And this week we're going to start building in some formulas. You'll see right here that there are actually 6 listed. Because if we have sine of an angle plus another angle, how this is written, we would use plus. If we have sine minus, then we use the minus. And look what happens on the cosine. If it's plus, we take away. If it's minus, we add. So is that clear now that I've explained that? So that dictates what signs you use, and tangent has top and bottom. Now, frequently in math you hear them say give an exact answer, right? And that means you can't grab your calculator. So this is where we give exact answers, and everything is in relation to our special triangles, those angles. However, we don't always have 30, 60, 90, or 45 degree angles. There are all kinds of different angles, right? So that's where these come into play. But rather than have you guys have to flip back and forth to your special triangles, let's take a second and remember that if this side is 1, this side is 1, and this is the square root of 2. And if we've got our 30, 60, 90 triangle, this is 1, 2, square root of 3. And then remember, depending on our quadrants, they're all positive here. Sine is positive here. Tangent is positive here. Cosine is positive there. Oh, and it looks like there's a misprint on this one. Find the exact value of, I want you to put sine, here, I'm just going to scribble that out, sine of 75 degrees. Set exact. I can't grab my calculator. And so what I have to do is, using my special angles, how could I add some special angles and get to 75 degrees? I'm just going to highlight, and I grabbed the wrong one. What is 45 plus 30? Is that the 75 degrees we're looking for? All right, so that's how this is going to work. We can say sine of 45 plus 30 is the same as sine of 75. So what we're doing is we're adding 2 angles together. And so I come up here and it tells me my formula. So we're going to call this guy A because it's first. This guy, well, I guess it's beta and alpha, how our formula is written. But if you want to call them A and B, that's just fine. If you had said 30 plus 45, the formula will work too. Okay, just keep track of which one is alpha and which one is beta. All right, so then it says sine of alpha. So I look at 45. Sine is opposite over hypotenuse, right? 1 over square root of 2, which we know is the square root of 2 over 2. And then it says times cosine of beta. All right, 30 degrees. Cosine. Adjacent over hypotenuse. Square root of 3 over 2. And because we're adding, what are we going to do in between these? Add. Now it says cosine of alpha. All right, our alpha is 45. Cosine adjacent over hypotenuse We know that's square root of 2 over 2 times sine of beta. Sine of 30, opposite over hypotenuse. Questions with how I set that up? All right, so then we have to manipulate using the fractions. We're going to multiply these together, and I get the square root of 6 over 4.
I've got a question.
Plus the square root of 2 over 4. Now I'm ready for your question.
How do you get the sine and cosine figured out for that one? I wasn't here when you were talking about that.
Use my special triangles in SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse.
I'm not sure how you decide which angle is which.
Whether it's alpha or beta?
Whether it's sine or cosine. Yeah, whether it's alpha or beta.
I could have said 30 was alpha and 45 was second. As long as I follow the formula, I will get the exact same answer, I promise.
Okay, so it doesn't matter exactly what corner you put as alpha and beta.
Nope.
As long as it's the two corners.
As long as it's alpha here and here and here. So as long as you're consistent, it will be just fine. We can take this a step further. We have common denominators, and that is your exact answer. It's not pretty, but that's your exact answer. I like this a little bit better than what we were doing last week because I feel like I'm not going in circles, but I don't know how you guys feel about it. Can that move?
It's not fully charged because I just had to go get it from somebody else.
Thank you.
Thanks. Sorry about that. I didn't get them back.
It's okay. All right, and then of course they give us information in different ways, right? It can't always be exactly the same for whatever reason. So sine of alpha minus beta, and it gives me some information, and so I've got to figure out what I've got going on. So this is what I recommend doing. We have in quadrant 2, which we know is here, the color's one right there, that I've got an angle, and you know it's always our reference angle right there, and then we drop and give ourselves that 90-degree angle. And it says sine of alpha is 5/13, so opposite over hypotenuse. All right, opposite over hypotenuse.
Is it 12?
So you've already done the Pythagorean theorem and figured out our other leg? It is. It's 12. I'll show you guys because he's right. I've got 5 squared plus 13 squared, whoops, plus b squared equals 13 squared, and then I get 169 minus 25 is 144. The square root of 144 is 12. He's absolutely right. Now, there's a little sneaky trick that if you pay attention to it here, it might save you some heartache later. Is this side of the triangle on the negative side of the x-axis? So if I just remind myself that that was in the negative direction, when I use that 12 later, it will always be negative. The 5 is positive because it's on the positive side of the y-axis. All right, so we'll keep track of that. Okay, so we just did this guy. Now let's do the other one. And then it says tangent of beta, and it's in quadrant 3. So 1, 2, 3. Drop and give yourself that right angle. Here is beta. So in this case, Jacob, they told you which one was alpha and which one was beta, right?
Mm-hmm.
It's defined. So tangent of beta, tangent is opposite over adjacent, 5, 12. Tell me about the signs on those. 5, are we going in the negative direction?
Yeah.
Yep. 12, are we going in that negative direction?
Yeah.
Yeah. All right, so now we're supposed to do sine of alpha minus beta. All right, so I'm coming up here so I can see that formula.
13's alpha.
All right, so sine of A minus B. So it says sine of alpha. Sine of alpha, opposite over hypotenuse. 5/13. Then it says times the cosine of beta. So I come down to beta. Cosine is adjacent over, whoops, I didn't figure out the hypotenuse.
It's 13.
Is it 13? I've got that 12 and the 12. Good. All right, so where was I? Cosine? Adjacent over hypotenuse. And because I paid attention to that negative, I didn't even have to think about it. It was already there. And we're doing minus. So minus says we're going to minus cosine of alpha, cosine adjacent over hypotenuse. And then sine of beta, opposite over hypotenuse. Those are at least numbers you could type into your calculator if you wanted to. We don't have radicals this time. But let's calculate what we got. So we're going to have negative 60 over 169 minus 12 times 5 is 60 over 169. They're both negative, so I get negative 120 over 169. Are we better with the formulas than we are the fractions, maybe? Should we do one more? All right, let's do one more. This one is tangent, so we'll be using that bigger formula, it feels like, for sure. All right, we've got to do the same thing. We've got to figure out our triangles. So alpha is in quadrant 2. 1, 2. Here is alpha. Drop and give yourself your 90-degree triangle. And its sign is opposite over hypotenuse. 3, 5. Yeah, this is a 3, 4, 5 triangle. Perfect. What do I want to do right now to take care of my signs so I don't have to think about it later?
Make it a negative.
Yeah, make that guy a negative. Now let's do beta. It's in quadrant 1. All right. Drop. Here is beta. And the tangent is 5/12, opposite over adjacent. How about that one, Jacob?
13.
Perfect. Are there any negatives I need to put in that quadrant? No. Yeah, they're all positive. All right. Tangent of alpha minus beta. Zoom out so we can see that formula, and then I'll zoom back in when we're calculating. All right. It says tangent of alpha. Tangent of alpha.
3 over 4.
3 over 4. And are we adding or subtracting?
Adding.
And what are we doing?
1.
So we're subtracting, which means we're going to be, so subtract is the bottom sign, so we'll use the bottom sign. And it says tangent of beta. Tangent of beta is 5 over 12 all over 1. Are we going to use the minus or the plus sign here?
Minus.
So remember, we're doing tangent A minus B,
Oh, okay.
and it's the bottom sign, so that means I will be using plus, yeah. Plus tangent of A, which was what? Oh, guess what we forgot, Jacob? We didn't put the negative right there. Tangent of A is what?
3 over.
Yeah, so negative 3/4. And then it says tangent of B. Tangent of B, opposite over adjacent, 5/12. And I could have remembered that I'd already looked for those there. All right, grab your calculator and do that, or do the fractions by hand. Either way, I know that I need to multiply this by 3 and this by 3. And I'm going to get negative 14/12 over, that's negative 15.
Over 63.
Tell me again.
63/48.
63/48 is on the bottom?
That's what it adds up to be.
Oh, on the,
Oh wait, I thought you would subtract there too. Because it's plus or minus the 1.
so back to our formula. Because it was minus, we use the bottom sign. We add. All right, so it's negative 15/48, which puts me at 33/48. How do we divide by a fraction? Multiply by the reciprocal. Oh, scoot on over. 12 goes into 48 4 times. 14 times 4 is negative 56 over 33. And you are totally welcome to grab your calculator and do it that way. You don't need to do the fractions by hand. So I think what we've learned in doing these couple of problems is pay attention to your signs. Number 1, on those triangles we draw, whether it's positive or negative. And then number 2, on your formula. Make sure you track which sign you use, whether it's addition or subtraction.